Hello all-nighters. Now we'll design a DFA for the language of strings which ends with 10. Basically, we'll write all the tuples initially. The first one is input alphabet. This is a language which consists of only 0 and 1. And then we'll write W, the input strings which are accepted by this language. The basic string which is accepted by this language is 10 itself. Next, it can be any set of 1 and zeros, but at last you have to get 1 and 0 because it ends with 1 0. So it can be 0 1 0, 1 1 0, 0 0 1 0, 1 1 1 0, so on. These are the W. Now let us construct a DFA for this. First, the foremost rule is construct the DFA, construct the transitions for the most basic string in it. Then we'll expand on it. Now, remember two things, that an initial state is represented with an arrow like this, and the final state is represented with a double circle. This is initial state and this is final state. Now, we'll start with an initial state. Let us assume it as Q0. And our most basic string is 1 0. So on 1, it should go to one state. Let us assume it as Q1. And on 0, 1 followed by 0, it should go to the final state because it is accepted by. So we'll represent it as a final state. This is the basic thing, and we will now expand on it. Next, we are done with 1 0. Now let us do the same for 0 1 0, and it should reach the final state. On 0 1 0, if we give a loop here, 0 1 0, it is reaching to the final state, right? So this is also done. Now here 1 1 0, 1, next Q1 on 1, we don't have any transition, we have to add a transition here, and on next we'll get 0, it will go to the final state. We can simply add 1 here. Now we got transitions, but we are not done yet because we don't have transitions from Q2 to Q2 on 0 and Q2 on 1. Now let us execute next string, that is 1 1 0. 1 1 0 is completed, sorry. 0 0 1 0, 0 0 1 0, it is going to final state. 1 1 0 triple 1, 1 1 1 0, it is also going to final state. But we must have a transition from every input alphabet at every state. At Q0 we have transition for 0 and for 1. Similarly for Q1 also we have transition from 1 and 0. But on Q2 we don't have transition for both, so we should add those transitions. Now Q2 on 0. Now listen to this carefully. Q2 on 0. If we get Q2 on 0, in order to get to Q2 we use the 0 as an instrument. So Q2 on 0 means we get something like 0 and 0 because the previous input alphabet is 0. 0 and 0 means it doesn't start with 1s, right? So we'll go to initial state directly on 0 and 0, and if we get 1, 0 and 1, Q2 on 1 will go to this state because we checked the input alphabet that we got 1 here. In 1 0, we got 1 here. We have to check whether the next digit is 0 or not. That's the only thing we have to keep in mind. If we got 1, the next thing we have to process is only 0. So we'll place it to the middle one because 1 is already checked by this Q1 state. Before we get to the Q1 state, we verified that 1 is already there. So this is the finite automata DFA for this. Now check whether all these, for every state on every input alphabet we have a transition or not. Q0 on 0 and 1, Q1 on 0 and 1, Q2 on 1 and 0. Okay, we have this. Now we have discussed another tuples, right? Q0, in this case that is initial state Q0 itself. Next F, in this case final state is Q2. This is the finite automata. Now let us draw the transition table for this. Transition table is very simple. Once you get to the finite automata, it is simply on 0 and on 1. We have Q1, Q, same. Initial state is represented with this arrow and the final state with the circle symbol. Now, Q0 on 0, it will go to Q0 itself. And Q0 on 1, it is going to Q1. Q1 on 0, Q2. Q1 on 1, so the same, Q1 itself. Q2 on 0 to Q0. Q2 on 1 to Q1. So this is the transition table. Now, let us take a random string which ends with 1 and 0 and verify whether it is accepted by the string. Remember one thing, if we take a string, if it is accepted, then it should end with 1 0 in this case. Otherwise, it should get rejected. It won't reach the final state. It will be in some random position other than final state. Take any big Z value, but it should end with 1 0. So consider this example 0 1 0 0 something 0. Now every time we'll start with this initial state. Q0 on 0 will go to Q0 itself. Next 1. Q0 on 1 will go to Q1. Next Q1 on 0 will go to Q2. Q2 on 0 will go to Q0. And Q0 on 1 will get to Q1 and last 0 will go to Q0. So this is a correct finite automata because it is verified for a digit ending with 1 0. Now we'll take an example which doesn't end with 1 0. Take a random example 1 0 0 1. Q0 on 1 to Q1, 0 on to Q2, 0 on Q0, and it will go to Q. On final one, it will go to Q1. Now here Q1 is not the final state, so this string is not accepted by the language where the strings end with 1 0. So this is the most basic example. If you understand this, we can build upon this and solve complex problems. Thank you.